The Multimedia Accordion Guide. The cents to tune the musette. 1 cent equals 1/100th of a semitone. The cent is the unit of measure that divides the semitone into 100 equal parts. The cents are used with electronic instruments. The cents get a different value depending on the octaves, contrary to the beat per seconds. Let's take a look at the beat rates obtained when applying a constant cent deviation to the second clarinet on the entire keyboard of a standard piano accordion. 12 cents applied at A440 Hz gives 3 beats per second. 12 cents an octave higher at 880 Hz gives 6 beats per second, a multiple of 2. The cent deviation of the first F divided by 10 gives the beat per second. The cent deviation at the last A corresponds to the exact beat per second. So if you apply 12 cents to the last A, you will have 12 beats per second. This table is important even if you don't plan tuning your own accordion. Indeed, it will help you to better choose your accordion according to your preferred style of music. You can use it as a basis. You may pause this video to study in more details this table. In this table, I've used the speed of 2 beats per second for the A440 Hz, but you can use another value and deduce the others using the Excel formula that you had with this accordion multimedia guide. For my part, I tune my own accordion with barely 1.5 beats second for the A440. There is a handy tool for tuners. It is an Excel formula in which all the calculations are done automatically to assess either the cent deviations or the beats per second. Here is a demonstration video. We will first familiarize ourselves with that formula. It looks intimidating first, but you'll see it's not that complicated. The first 3 lines each have a box where you will enter values. Whenever you enter a value in either of these boxes, you will see the bottom of the formula change to reflect the data for the value you entered. The first line is for the tuning standard. You will change the value of this box only if you want a different pitch from the standard A440. If you want to tune to A440 standard, then you will not change the value of this box. If, on the other hand, you want to tune an accordion to A442 Hz, you will enter 442 in this box so that all values you enter are relative to A442. It is mainly in the other 2 boxes that you will enter values. The second box in blue represents the speed of the beats per second that you want to reach. The values entered here will be reflected under the blue columns labeled for beats per second. The third box in the green represents the cents you want to reach. The values entered here will be reflected under the green columns labeled for cents deviation. The first column A corresponds to the number of the note, the second column B, the name of the note, the third column C, the octave of the note, fourth column D, the real frequency in hertz of the note, fifth column E, the frequency obtained according to the values entered in the blue box, beats per second. The sixth column F, the values in cents corresponding to the speed of beats per second entered in the blue box. The seventh column, G, is the frequency obtained according to the value which you will have entered in the green box. The eighth and last column, H, represents the equivalent of the cents entered in the green box but in beats per second. The blue lines between notes 36 and 91 represent the chromatic accordion's total range. The yellow lines between note 41 and 81 represent the piano accordion's total range. The gray lines are simply the A notes, and they serve as a guide. Let us now give it a try. Let's try a beat rate of 2 beats per second. So, when we enter 2 beats per second in that box, we immediately see that the columns under the blue box, 4 beats per second, change instantly. It can be seen on line 57, representing A440, that the frequency obtained is 442 Hz. So 442 minus 440 equals 2 Hz difference. So this A will have a 2 beats per second beat rate. If we go down an octave lower, we see that we also have 2 beats per second. And the higher octave also gives 2 beats per second. So, we can assume that a difference of 2 Hz will always give a 2 beat per second as the beating rate, regardless of the octave. We also see that for cents, it is not that simple. Indeed, at the frequency of A440, we must put 7.8 cents to obtain a 2 beats per second beat rate, while at an octave lower, we must apply the double, that is to say 15 cents. Same as if you want to obtain a 2 beat second for the A880, you only need to apply 3.9 cents deviation, and so on. Let's clear the beats per second box and enter 8 cents in the green cents deviation box. If we go on line 57, we see that with 8 cents added, we will have a beat rate of 2 beats per second. But if we go just an octave higher, we see that the beat rate is already double. A 4 beats per second for the first A above the A440 is too fast. And 8 beats per second for the highest A is also too fast. So, this is where we will play with multiple values in order to follow a smooth curve for increases in the beat rates when going up. Note that it is good to have beat rates that go up faster in the treble, but you don't want to overdo it. We will see later what beat rate progression curve is ideal. Thanks to this Excel formula, now you can also experiment according to your personal taste. Now go and may the angel's voice come out of your accordion.